Ever wondered why some systems, whether a farm, a business, or an AI model, run like clockwork while others stumble? It's not just about hard work. It's about efficiency. But here's the catch. When you try to measure efficiency, too much data can actually hide the real story. Today, we're diving into a groundbreaking study that's changing how we spot inefficiency in complex systems, and why a clever tool called Lasso is helping us cut through the chaos. Let's start with a simple example. Imagine you're a farmer trying to figure out why your crop yields are lower than your neighbor's. You've got data on everything: soil quality, rainfall, seeds, labor, even the color of your tractor. But here's the problem. Some of these factors don't actually matter. They're like noise in a crowded room. So much stuff is happening, you can't hear the real conversation. This is where efficiency analysis comes in. Think of it as a detective tool. It helps us separate the real inefficiencies, like poor farming practices, from random stuff like a weird weather pattern. But here's the catch. When you throw too many variables into the mix, the detective gets confused. The data becomes so noisy, the signal of inefficiency gets lost. In traditional methods, like the ones economists have used for decades, adding more variables makes it harder to spot inefficiency. Why? Because the math gets messy. The key clue we use is something called skewness, a measure of how lopsided the errors in the data are. But when there are too many variables, this skewness disappears, like a whisper in a hurricane. So how do we fix this? Enter Lasso, a machine learning tool that acts like a superpowered filter. It helps pick out the most important variables, like soil quality or labor, while ignoring the rest, like your tractor's color. But here's the twist. Using Lasso in a two-step process, first selecting variables, then estimating inefficiency, can sometimes miss key factors. This is called omitted variable bias, and it's like leaving out a crucial clue in a mystery. The study we're looking at tested two approaches: post-single lasso (PSL) and post-double lasso (PDL). PSL uses lasso once, while PDL uses it twice, first to select variables, then to refine the estimation. Why does this matter? Let's break it down. Imagine you're baking a cake and throw in every ingredient from the kitchen. Your cake might end up tasting like a science experiment. Similarly, when models include too many variables, they start producing weird results. For example, a model might suggest that more land reduces output, a clear contradiction. This happens because the noise drowns out the signal. The PDL method is like a smarter recipe. It filters out the irrelevant ingredients, keeping only the ones that matter. Suddenly the numbers make sense. More cows mean higher output, more feed means better results. Efficiency scores jump up, like a fitness tracker finally showing progress. But here's the twist. How many variables you keep can change everything. Sometimes the model grabs all 51 possible factors. Other times, it narrows it down to just 23. It's like choosing ingredients for a recipe. Too many and you're lost. Too few and you miss the magic. The key: finding that sweet spot where the model isn't overcomplicating things, but still catches the real patterns. And the winners? The PDL-COLS and PDL-MLE methods. They're like the Goldilocks of variable selection, just right. They avoid the pitfalls of overfitting, where a model memorizes the data but fails in real life, and underfitting, where it oversimplifies. By using a two-step lasso process, they strike a balance between complexity and clarity. So what's the takeaway? In a world where data is abundant, but insights are scarce, tools like PDL are revolutionizing how we uncover inefficiencies. Whether you're a farmer, an economist, or a data scientist, this study shows that how you handle your data matters more than how much you collect. Thanks for watching. If you want to dive deeper into the math behind PDL or see real-world applications, hit the links below. And remember, efficiency isn't just about working harder. It's about working smarter. Until next time.